Welcome to continued instruction on polar coordinates. So now we're going to look at some graphs that create what they call roses in the polar world, okay? So here's what's going on. Notice that you've got an amplitude of 3, you've got sine of 2 theta, so we've got a little bit of a compression here horizontally. So notice that we have these little branches, right? So these little arches of your trig function, your sinusoidal graph. If you start off at 0, again, starting at 0, facing the 0 direction, with sine we start at 0. So we always start at the origin, and then as we spin, we progress out. Notice that here we are at pi over 4, and we are all the way out. So in your rectangular, it's a distance from the x-axis up of 3. In polar land, we're facing pi over 4 and we're out 1, 2, 3 units. And even though there isn't a polar grid there, imagine that's 3 along that circular path, right? Okay, and then boom, it gets sucked back into the origin. When you get to an x-intercept, that brings you back to the origin here. So it kind of pinches off a petal is what we like to think in that first. Now, as you progress from pi over 2 to pi, notice that you have negative output values. So as we're going from here to here, what actually is happening is we are creating this pedal. So as we spin from here, we progressively walk backwards till we're walking backwards the full distance of -3 when we're facing 3 pi over 4, which would put you here. And then boom, once we get to pi, it pulls back and this pinches that second pedal. And then we're rocking in the correct direction, the positive direction. So every time your graph rectangularly is above the x-axis, we're walking out, right? We're making positive, walking in the same direction that we're facing. And if your y values are negative, we're walking in the opposite. So from pi to 3 pi over 2, we're going out to 3 to our pi over 4 angle and then pulling it back in here. And then here to here, we are spinning from 3 pi over 2 to 2 pi, except we're walking backwards and we're making that, okay? I just really make these graphs ugly, don't I? Okay, so now, come back. Okay, graph the polar, blah, blah, what does it say? Are you like me and like to try to read the least amount that you can? Graph the following polar equations, then check for accuracy on the, yeah, oh yeah, we should probably do that. I will put a little video on how to do that. Anyhow, so starting off, what we're going to do is take a look at our rectangular graph. So in our rectangular graph, when we are at 0, we're out at 4. So here we are. Now notice when you're dealing with cosine, you start out at your farthest distance, which means your pedal will be kind of symmetric on that x-axis, whereas with your sine, we started out at 0 and then progressed, okay? So pay attention to that. So now it pulls back. If this is pi over 2, at pi over 4, so when we're facing pi over 4, it pulls back. So what happens is it goes like that. So that's that. And now we're going to be walking backwards from pi over 4 to 3 pi over 4, which means, all right, where's our farthest backwards direction walking out or walker out of is pi over 2. I'm sorry, I should be more serious as a math person, right? When you walk back, when you're facing pi over 2, which is this direction, we're walking back 4, right? So then it'll pull back in when we get to facing 3 pi over 4. And then as we progress from 3 pi over 4 to 5 pi over 4, pi being in the middle, is where we walk forward. And when we're facing pi, which is right here, we'll walk out total distance of 4. So there you go. Boom, boom, boom. That's ugly, but whatever. And then from here to here, we're going to pinch up another pedal where we're walking backwards from facing this direction to this direction. And at 3 pi over 4 is when we walk backwards our farthest, which is at there. And then this little piece right here will come along and finish up that pedal nice and pretty. All right, so that's what's happening there. Now these are called roses, and notice that when you have 2 theta, right, you're getting 4 petals. So that's something to notice. Just, okay. So the next one right here, I'm going to go ahead and pause and notice this. You've got a difference here. Notice that your amplitude is bigger or greater than the absolute value. Well, actually amplitude is the absolute value, so this value 4 is greater than your midline 2, which means that you've got a little bit of graph below and a more graph above in this particular case. What happens when that happens? Actually, let's just go through it. So starting off, if you start off at 0, right, sine of 0 is 0, this whole part goes away and you're dealing with 2, and you can see that on your graph right here. But say that you didn't have your rectangular graph and you wanted to kind of figure out where you were at quadrantally. So at 0, that all goes away, you start at 2. There's where you're at. Now, when you get to pi over 2, that's when sine is at its highest value, which is positive 1. So this ends up being 2 minus 4 times 1, which is minus 4, which ends up actually equaling negative 2, right? So when you're facing this direction, you're back at negative 2, which is right here. And notice that somewhere in between here, somewhere in between that, as you came back to 0 here, when you progressed through, you came back to 0, and when you were facing pi over 2, you were walking back to this 2. So what that looks like is we get back to 0, and if we're facing pi over 2, we walked backwards all that way to get there. And now when we walk from pi over 2 to that value, it's going to come back in and pinch off a little kind of loop inside of there. So everything that's below here creates this loopy situation. And now we are progressing out to 2 by the time we are facing pi, so there's that point, so then we'll get to here. Now when we're at 3 pi over 4, we're at a total distance of 6, and you can do that in your mind. When you're at 3 pi over 4, sine is equal to negative 1, which would make this positive 4 to add to the 2, which gives you a distance out of 6. Now again, even though that says negative 6, we're facing 3 pi over 2, so that's a positive progression out to here. Boom. So that's what happened here to here. And now you're going to pull it back in. Pulling it back in, and then when you pull it back in to the 0 right there, right, what's going to happen is it should go back to the origin. But know this, that we started off at 2 and our cycle is over right there. So really, as we pull to here, we're going to, this is pi over 2, this graph went too far. You're like, you're messing with my mind, man. So that pulls right back to there, and imagine that that's a pretty graph, okay? So that's how that one progressed. Now, what you are going to want to do, for example number 5, is try to figure out what would be the polar function for each of these graphs. And you might have to mess around a little bit on your calculator. So what I'm going to do is I'm going to give you a little bit of instruction with your calculator. Okay, so I grabbed my calculator. I forgot to tell you to grab yours. So grab your calculator. You can pause this for a minute. But the first thing that you want to do is you want to go into mode right here. And in mode, you want to go down to where it says function. You want to go over to polar. Okay, it's not wanting to do it for me. Okay, I have to go like this apparently. Oh, it just won't let me touch it. That's not nice. Okay, so anyhow, okay, I'm gonna get it. Boom. There we go. Now press enter, don't laugh. Okay, now go back to your y equals, and all of a sudden it says r is equal to. Okay, what we're gonna do is we're gonna type in the sine of, let's put 2 theta. Notice that when you press your little X key now, it turns into theta, which is wonderful, right? So I want to go ahead and do that. And also we're going to go to the window and want to point some things out here. So your minimum theta is going to be 0. We're going to go down and put in, how does this work? Yeah, put in 2 pi, which I already have in. So hit 2 and then pi, so that we're going to, our angles are going to progress just from 0 to 2 pi. Now, I'm not sure if you graphed in parametrics before. We didn't have to do that in this class, but the T step right here basically is going to give you how many data values you're going to have. I like to keep it at pi divided by 12 so it fills in nicely. So pi divided by 12 right there is good. All right, and then the rest of this is just your x coordinates. So let's go, let's do a -5, +5, should be okay. and then minimum -5 and a +5. Okay, so now we're gonna hit graph and watch what it does. Oh, that was fast. So what we can do if we want to slow that down is go back to window and go down to your T-step so it'll graph slower. So we can hit pi maybe and divide it by, I don't know, let's do 24, and then hit graph and it'll go a little slower so you can see that. And now I'm going to go back to my y equals and I'm going to insert in front here. So I'm going to insert a 4. And what that'll do is that's going to make your petals go out a farther distance of 4, right? Now notice this. Now here's what I want to show. And also if we want to, we can do a zoom square so we can actually see, you know, I always want to just touch it. I'm not really good at this computer graphing calculator. Hit enter and graph. This will make it show you what it actually looks like rather than it all spread apart left and right. Okay, so that's what that looks like. And so notice that there are 4 petals. So here's what I want you to do. Think about how many petals there may be if I put in a 3 right there, okay? So you're thinking twice that being 6, but it actually isn't. What happens here is that it'll retrace these. And if we want to do a trace and go through it, watch, it'll go through and it'll trace, and then it'll do it again through 2 pi. So that's what's happening, is it's going over it again. So what happens is that if you have, we'll go back in here, if you have an even amount for your B value, let's make it 4, it'll double that. See? Now these should be a little bit more rounded. It's just that the T-step actually does that. So if we changed our T-step, now I'm going to make a really long video, sorry. If we go to window and change our T-step to like, watch this, 0.001, watch how slow it'll go. Then it's gonna like inch along, but watch how pretty the little petal will be. It'll be all nice and round, but nobody wants to wait that long. So clear, enter, or clear on and in that madness, go back to your window. So that's kind of like what your T-step does, or your theta step in this case. So we can just go ahead and put 0.01, that might be good, right? I mean, I don't have to do it in terms of pi. Boom. Hey, actually, that's nice. So this is what you do. You go in and you play with it. That's not too shabby. All right. So if you look, what if we change this now to cosine? Does cosine change anything? Will it make double the odd petals? No. What it'll do is it'll be aligned with your x-axis. So it starts out at the, so if you have it aligned with your x-axis, you know that that one's cosine. Okay, so that's how you can do this on your graphing calculator in polar mode. Now I'm going to go back to our other, let's see if I can just, wow, look at that. Okay, go ahead, I'm going to pause, and you can use your calculator and mess around, see what you come up with. See if you can come up with the equations for these. I'm going to pause and then I'll write them in, and you pause as well and come back and check. Okay, pausing now. Okay, how did you do? Did you make your theta values better than I did? Did you get -3 cosine? Negative because it's on the negative part, cosine because it's along the x-axis, right? 5, distance out, 1, 2, 3, 4, 5 is your amplitude, sine of 2 theta, because double that gives you 4 petals, right? So wondering if 3 is the only odd number. If you did 5, there'd only be 5 petals. Cosine, notice that the petal starts at the height, at the farthest distance on your x-axis, but for sine it starts at 0 and then progresses to the farthest distance. And these are ways in which you can kind of figure it out. And if that's hard, here is some common graphs and a little bit of information. So the cardioid one, notice where it comes back, pinches in and goes out, is when, you know, these conditions are met. This is where these conditions are met. The inner loop. Here's what I know is that if your A and B value are exactly the same, so basically that's what this is saying, it comes back. So like your polar graph, or not your polar graph, but your rectangular graph will come down, touch it, and then move away. If you have any part of your graph that comes down below like that, it creates this loop that goes backwards. So obviously this one's aligned with cosine, this one's aligned with sine because of where they have it. This is just go through and mess around with these a little bit to learn. But really, as it comes down to it, you can always just use your calculator to answer the questions in this class. But having this knowledge of how they relate to the rectangular will help you with doing the calculus portion, which is finding the areas. All right, hope that helped. And by the way, there's some more coming up, so we'll just do those real fast in the next video.